This one is the third lecture on this series, and I'm going to discuss the efficiencies of solar cells. This series may not be further updated for 1 or 2 years before anything meaningful can be accumulated. Please subscribe and press like button if you want to support this channel. For other lectures of mine, you can search Theochems RE, which means the renewable energy of a theoretical chemist. Specifically, you can refer to lectures 1 and 2 on this series for a better understanding on the terminology used here. First, I'll just summarize pros and cons of various solar cells. Silicon solar cell, SSC, is based on the technology routinely established for a silicon semiconductor. It should be hundreds of micrometers thick. On the other hand, Perovskite solar cell, PSC, does not have to be so thick to function properly, and the thickness of hundreds, thousands of that of the PSC is enough. In addition, it's very easy to synthesize. On the other hand, the PSC should include lead, which is a very toxic element. In addition, it is unstable in the presence of humidity. Organic solar cell, OSC, is advantageous in that it is flexible but has low efficiency. This slide is only for those who want to know more about the PSC, and I will not go into detail. As long as the photoconversion efficiency, PCE, is concerned, multiple junction is better than the single junction. For example, SSC/PSC exhibits the PCE greater than 30%, which means that SSC and PSC are combined in one cell. Please refer to Lecture 2 for official certification sites. Here, let us talk about the efficiencies of cells and submodules. This table shows that the PCE of the single junction PSC is comparable to that of the SSC, which are less than 30%. On the other hand, the OSC exhibits much lower PCE of 15%. LONGi of China and Jinko of Australia are leading the PCE of the SSC, and it is worth noting that the former is actively involved in the commercialization. On the one hand, AIST of Japan and the Fraunhofer Institute of Germany are at the forefront of the PSC and OSC respectively. Now let us focus on the typical cells of multiple junction, the PCEs of the SSC/PSC by Saudi Arabia and China reached 33%, which are record highs. On the other hand, that of the PSC/PSC is slightly lower than 30%. Finally, I am going to discuss the PCEs of solar modules, which are ready for commercial use. The table does not show the data for the PSC, since it has not been commercialized yet. The efficiency of 25% has been remarked by the SSCs of United States, China, France, and QCell of Korea. Particularly, the Chinese Institute has developed a flexible SSC which may have a high impact on the application in buildings and automobiles. Thank you for watching.